everyone. I'm so happy to see you here. And before I begin, can we give a round of applause to our amazing host who is making this so much fun for us? Thank you so much. So my name is Alina, and this is my second year at SpringIO. Last year, I was also here for the first time, and you were all very nice and kind and friendly to me. So I had a really great time last year, and I'm really happy to be back. As you could have guessed from my slides and my job position, I'm working on GraalVM. So in this session, we will talk about everything you need to know about GraalVM for Java, and more specifically for Spring Boot applications as well. Let's go. So a few words about myself. This is my name, and this is my handle. You can find me on any kinds of social media if you want to ask some kind of follow-up question, ask me for the slides, links, demos, etc. And I'm a developer advocate for GraalVM at Oracle, and more specifically at Oracle Labs, which is this very cool R&D unit at Oracle, where we're doing a lot of research, and we originate back from the Sun Microsystems days. So we've been doing a research project since then, and GraalVM has been one of such research projects as well. I love open source and communities. That's why I like coming to places like this, where I get to talk to people in person. And I love both programming and natural languages. Now, a little side note, this morning, Josh in the keynote talked a lot about his dog and how awful he is, but how important it is to adopt dogs and animals in general. And I want to add to that story and maybe balance things out a little. This is my cat. She is also adopted. I love her. She's been living with me for the past 11 years. So if you want to get a pet, if you're ready to adopt, consider adopting a pet from a shelter rather than buying, and I will promise you, you will be super happy to have pets. Thanks. So we will get back to pets in a second, but before that, let's talk about GraalVM. So what is GraalVM, and when should you use it, and how exactly? So one thing to keep in mind about GraalVM is it is a JDK, and this is sometimes a lesser known fact because many people focus on native image, and there's a ahead-of-time compilation part of GraalVM, but it's more than that. So it's a JDK, and we just add things on top of the JDK, and pretty much anything you can do with any other JDK of your choice, Oracle JDK, OpenJDK, etc. You can do the exact same thing with GraalVM and more. So we just add more things. You can run more languages on GraalVM, or you can also do this native compilation, where you can build a native executable version of your Java app and deploy it as a native application. So it's kind of important to keep in mind that when you're using GraalVM, you get to make this choice. It's not necessarily a one-way street, where if you're using GraalVM, you have to do native image compilation. I think you should. It's really great, but also you can just use it as a JDK, and you can easily get maybe 10–15% performance improvement just by moving to GraalVM as your JDK, and migration path is very easy. So if you want to stay in this JVM, JIT world, you can still do it with GraalVM, just with a better, newer compiler, or you can use native image and do ahead-of-time compilation of your applications. So when I come to conferences, sometimes I get this kind of tricky question, when should I not use GraalVM? And my answer is always use GraalVM, but choose which part of GraalVM you want to use. So do you want to stay on the JDK, or do you want to do native image? Because you can do both with GraalVM. Now, before we start talking about more things, I want to try to repeat what the people did in the keynote this morning. And I only set it up during the break, so this might fail terribly. But let's see if we can make this work. How do I make this full screen? I guess it's as full screen as it gets. So if you can maybe scan this QR code and try answering this question of how familiar you are with GraalVM, maybe we can have some live stats, and we can just hope and pray that it works. OK, it does work. Look at that. OK, I voted as well. Let's see. And I guess you can vote countless number of times, so I can fake the data, but I wouldn't. So let's just give it another maybe 3 seconds for people to vote, and let's look at the results. OK, so what's the trend? About 10% are using GraalVM, and I would say this checks out comparing to what we saw this morning in the report that Sebastian has shared. And also about 30% are currently evaluating and planning to use GraalVM. So pretty much the same data that Sebastian showed this morning. It almost looks set up, but it's not. You can see that this is happening live. So thank you a lot for this voting, and thank you for your attention to GraalVM. We are really working on making it even more usable, friendly, and beneficial for you. OK, with that being done, I'm wondering if I can close this. Yeah, maybe I can just kill the tab, and thank you for voting. OK, killed. And let's go back to the presentation. So talking about GraalVM and how you are using it, and since when you started using it, I want to show you this slide about our history. So I mentioned that GraalVM has been a research project originating from labs, and it took us almost a decade of research to make it happen. And then I like showing this slide because A, I think it's a beautiful slide design, so I'm just proud of my team's design skills. But also there are some important milestones here. So in 2019, we went GA with our first production-grade builds. So after all the research, after all the beta releases, we released our first GA version. Then in 2020, I like this milestone a lot. So Alibaba started using GraalVM and native image in production. And it might seem like GraalVM is this huge, revolutionary, kind of groundbreaking, maybe even a bit scary technology. And in a way, it is. But there are people who have been using it for the past 4 years and under huge load. As you can imagine, Alibaba, what kind of traffic they have. And they have been very happy with it ever since. So I really like this story. And getting closer to Spring and what we are talking about here today. So in 2021, the project called Spring Native went beta. After the years of research and working with the Spring team, there was this Spring Native project released. And then in 2022, you can now use, since 2022, you can use GraalVM in your production Spring project. There is GA support out of the box for GraalVM and native image compilation. So let's talk about this native compilation and how is it even possible to take something as dynamic as a Java application and compile it ahead of time. So how does it work and what are the things that you need to keep in mind? So when you run your native image command and as an input it takes bytecode, so you need to give it either your jar or your class files, it will look at your application starting from its main entry point and it will try to find all the code that we call reachable. So the code that is actually necessary for your application and that is involved in what your application is supposed to be doing so that it can eliminate everything that you are not using and then just put only the things that you need in this final produced native executable. And this applies to your user code, the code that you wrote, but also all of your dependencies and even the JDK classes that you are using. It will analyze your whole project basically and then put the things that you are using into that native executable. That is one part of the story, but there is also another interesting aspect. So as we are doing that, we will also take a look at your heap, and we will define which objects in the heap are safe to initialize at snapshot at build time, so that you can also start your application when you start natively for the first time, and you can have your heap pre-populated for you, so you can start much faster and not spend time and resources allocating those objects. And then in the end, what you get is a native executable that is specific to your platform, to your operating system, to your architecture. And the cool part is that it starts very fast and it can run very fast because it doesn't need the JVM to run anymore, and it doesn't need to do all of that JVM warm-up work anymore. Now, with that said and being done, let's maybe look at the demo and see how that works in action. So let's start here. Let's clear this up. And the first thing I want to start with is my native Spring Boot app. There is a bunch of things here, but for the sake of this first part of the demo, let's just focus on the fact that I have my Spring app. And I have this hello controller that returns a message. So let's see if we can run this so far. Let's check my Java version. And I'm using GraalVM for JDK 23. So you know JDK 23 will be released only in autumn in September, and GraalVM is being released on the same dates as OpenJDK. But you can already give a try to our early access builds. So if you want to be a cool kid, use all the latest bleeding edge technology, and also give us feedback about GraalVM, you can use early access builds. And what I also really like about this, if you are using SDK-man, can you raise your hand if you're using SDK-man? As you should, it's very cool. So you can install GraalVM with SDK-man and even early access builds. They're also available there. So this is how I got my GraalVM set up here. So I said it's a normal JDK, right? So let's go ahead and run this. My one Spring Boot run. And it starts in something around 1.1 seconds. So let's go ahead and see if we can get our hello message from there. And we get our message. So far, so good. Nothing, exciting yet. It works, but we expected it to work. So let's go ahead and let's compile it. And I have a bunch of profiles, but for the sake of this demo, let's just do plain native. And let's do native compile. And now it will start a native image build. You can see that it's looking at the application, loading all the necessary things. And now it will actually start analyzing my app, see what are the options that I have passed, what is on my class pass, and what is supposed to happen for my application to be actually working. And you can see this output, I think, is very cool. So it shows you a lot of interesting info on your system, what is going on, how many resources it has found, what is happening in the app. And the part that I want to emphasize here when the analysis phase will be over is how big my app is. So this is my actual application. There are a few class files, but nothing too exciting. But also there are some dependencies. So there is Spring, Spring Web, native image, there is my JDK. And even this, I would say, fairly trivial app, if you try to analyze what's going on there, so this is showing me how many fields and methods are reachable out of my complete project. And even for this trivial app, it found out that there are 25K, okay, go back, 25K reachable fields and almost 90K reachable methods. So what I'm heading with this is sometimes if you're building a bigger application with native image, you can say, okay, it takes a few minutes, it's kind of too long, I don't have this kind of attention span, why does it have to be so long? But what happens there is that native image looks at your application and it's trying to build like a whole universe of your app and understand what is going on there and include everything needed. And as you can see, even for a fairly trivial Java app, it's quite a few things. So discovering all of that, compiling, optimizing, building ahead of time, I feel like this is a fairly accessible time to build my app. I've kept talking, but actually the build has finished in 46 seconds. So let's check what it has produced. Target, this is my demo. Time zone differs because it's a cloud instance, but it's on. And then we can run it, target demo, and it runs, only now it starts just in 46 milliseconds. And if we go back here, it's still returning our message. So far, so good. But startup is not the only important thing that can be valuable to you in your application. So I want to do a quick, I would not even say benchmarking, but just see what else we can measure about our application. So let's do this, user bin time v, and it will start our application again. Only this time we will send some requests. This will not be a proper load testing. We will do load testing later on. But let's say our application is running, users are sending some requests, it's experiencing some kind of load. As I'm speaking, I've sent maybe 25, 30 requests. So let's kill it, and let's see what we get here. So there's a number of things, but one that is interesting for me, I would like to talk about memory usage here. And we see that maximum RSS of my app is 68 up 8-ish, I would say, megabytes. And I would say this is quite good for an application that is a web app available to serve requests, doing its job, and this is all the memory that it's using. And also notice that I was not limiting the memory in any way. If I wanted to reduce the memory usage, I could have done so. But this is just out of the box, having the whole machine available, do your best, pull as much memory as you need, and it's only using, I would say, less than 70 megabytes. So this is pretty cool, and you can take it down even further. And talking about memory usage, I like coming back to the session that Josh Long and James Ward did a couple of years ago when they were introducing Spring Native. There they did a similar thing. So they built a Spring app, and at the time, I think it was consuming maybe like 100 megabytes. And they said, hey, how common it is that you deploy a Java application and you give it 1 gig of memory? Like, raise your hands. And many people raised their hands. And they said, hey, so for that 1 gig, you can deploy 10 such instances of an application, or maybe for 1/10 of that memory footprint, you can already have your instance running. So how cool is that? And I think it's a great benefit of native image. Startup is great, but memory usage and resources usage is even more important. So with that, let me go back to my slides, and let me talk more about native image. So what are the benefits? If you have heard about GraalVM and native image anything at all, you probably have heard that it's great for fast startup, and indeed we saw that in the demo where our application started in something like 46 milliseconds, and it's indeed very cool. But you can say, hey, I can see how this is great for microservices and serverless applications, maybe for CLI apps, but what if I have a longer running application that I build and deploy, and then it runs for hours, days, weeks, and I don't care about startup that much? And I agree with you, it's not the only benefit that you could care about. That's why, thank God, there are more things that native image gives you. So I have showed you the memory usage, but it applies to everything. So a similar thing applies to CPU usage. And this comes from the fact that You remember that slide where I was talking about native image and how it builds your application? So what it does, it offers you to shift all that work of loading your classes, analyzing, compiling, etc., profiling, shift it from runtime to build time, so you can do it once, and you don't have to repeat it every time you're starting your application. And I think for many applications, this makes a lot of sense, because chances are that you build your application once, and then you deploy it many times, so it makes sense to shift all that work to build time. And it's also beneficial if you think about it. So when I showed you the native image build, and I talked about how it takes longer than your normal Java build, but it's because it does all this valuable, important work. It does a lot of work, and it does need some resources as you're building your application. But the thing is that JVM does pretty much the same thing, only at runtime, and it kind of more evenly distributes that work across runtime, while native image offers you a trade-off where you move it to build time, and then you don't need to do it anymore at runtime, which results in fast startup, but also lower memory usage. So lower memory usage, lower CPU, lower electricity usage. So if you care about your cloud bills or infrastructure, or if you are maybe caring about the planet, so you want to save the turtles, save the trees, use fewer resources, native image could be helpful for you to accomplish that. And we will talk about performance later on, but also native image gives you very predictable performance over time. So your application is immediately available as you start it, and it works very fast from the beginning, which you will see in the performance demo. And I also like the way, for example, Sebastian from the Sprint team talks about this. He calls this instant performance, meaning that your application is readily available as you start it, but also it offers you good performance immediately upon startup. So if you want to have predictable performance, but also predictable resources consumption profile, it's something that native image can give you. Now, what's interesting, native image also gives you additional security layer on top of what JDK gives you. So because of this ahead-of-time compilation under a closed world assumption, some things in Java, such as reflection, serialization, etc., are possible, but they require a bit more kind of control and awareness from you, an explicit allow list coming either from you or your framework library, etc., to make those things happen. So they cannot happen without your awareness and control, and this adds additional kind of security and protection layer to your app. And also, there is no JIT compilation anymore at runtime. So for example, those attack vectors that target the JIT compiler specifically are just not possible in native image because there is no JIT compilation happening anymore. It also gives you compact packaging, so maybe we will look at the image size later on in the presentation, but if you want to have smaller container images or just smaller native executables, fully complete, fully working out of the box, it's something that native image can give you. And it's also fairly easy to build applications now in 2024 with GraalVM because we have all this great support from all the frameworks and all the cloud vendors. Okay. And let's talk about Spring and GraalVM and how they come together, and what is this Spring AOT thing, and why do we need it? So one thing about Spring and the way Spring applications work is that when you run an application, let's say on the JVM, in the beginning what needs to happen is that Spring needs to analyze your application, look at the app, look at the class files, look at the config, pull it from all the places, pull them together and kind of build an universe or idea of your app and how all those things come together, and then have an idea of your application. And this is happening at runtime when you first run your application. Now, what's interesting, native image is doing pretty much the same thing. So when we were talking about the build process, we said that native image is trying to discover your application and understand everything that it does, and also pull all the available config from all the places and have the idea of your app. So it's doing pretty much the same thing as Spring does, but native image does those things at build time. And Spring traditionally normally would do them at runtime. But those two things come together nicely for Spring to work with GraalVM and native image because of Spring AOT. And Spring AOT is this new module and engine in the Spring framework that plugs into your build when you run, for example, your native image compilation process. And it assists native image and transforms your application in a way that is easier for native image to consume and make sense out of. So specifically, what Spring AOT will give you is Java source files. So for example, if you're using some configuration, it will transform it in a way that is more friendly towards native image. Some people call it beautiful functional configuration that is the output. For me, it's slightly less beautiful or like more challenging to see the beauty of it, but it doesn't matter because it does it automatically for you. It will also generate the bytecode for things like proxies, and it will also generate hint files for things in native image that are a bit more challenging for it to understand at runtime. So because native image compiles the application ahead of time at build time, it does so under closed world assumption. So those more dynamic Java features such as reflection, serialization, proxies, loading resources, etc., those require a specific way to tell native image, hey, this will happen at runtime. Please make those things possible to work at runtime. Because under closed world assumption, before the runtime has happened, technically there is no way of knowing about those things, but luckily frameworks and configuration can do those things for you and enable them in native image for you. Now, I want to talk about how you can use those what I call dynamic Java features, so reflection, serialization, etc., in GraalVM and native image, and how you can use libraries leveraging those features, how you can make those things work. And this will be a bit complicated, but I think this is a very important slide, so I want to show it to you. So how many of you have heard that GraalVM doesn't work with reflection? Okay, some people, not that many, thank God, but still some people have heard it. I've heard it as well, but this is not true. GraalVM does work with reflection, but there are things to know. So some more predictable, trivial calls to the reflection API, native image can even automatically figure out of the box. But then if you're doing something more advanced or unpredictable or non-trivial, it would need those hint files coming from your framework, library, yourself as a user, an agent, etc., to tell native image, hey, this will happen at runtime. So how you can make those things work with GraalVM and native image specifically? So one good way to work with libraries that are using such dynamic Java features or libraries that you want to embed into your native image application is that if a library is built out of the way in a way that is friendly, out of the box, in a way that is friendly towards native image. So lately we see a lot of posts like this where some new library authors and maintainers say, hey, I have built this application, it's a library or a tool, you can use it, and it's native image friendly out of the box. And this is the best case scenario, and each bullet point here represents ways how libraries can work with native image, going from the best case, kind of ideal scenario to a scenario where it needs a bit more work from your side. So the best case is if a library is built in a way that is friendly towards native image out of the box. Now, if that is not the case, the next best thing a library can do is include a config for native image within the library itself. And here I used to show a demo where I had an H2 demo that would not work with GraalVM unless I provided a config. But now, luckily, I don't have to do it anymore, because if I go to H2 and I look at the source code, there is this little reflect config JSON file within H2 itself that tells native image, hey, please make those things available at runtime, because our users will use those things from H2. So if you, I mean, this is still experimental for H2, but if you'll be using H2 in your native image build, this will be used to assist the native image compilation. This is one good option, but not all of the libraries have included config for native image yet. Some of them are still working on it, or maybe they haven't gotten to it yet. And it seems like there could be a central place where you as a user or maintainer can contribute those hints for native image so that others can reuse it. Because, for example, maybe if I have discovered this thing for H2, other users don't have to do it. They can just use the same config that I have. So indeed, such place exists. We have created this on GitHub in a collaboration with many framework teams. And here we are looking as an example on a native and configuration files for native to work with native image. But that is the case for many, many popular libraries out there. So from this centralized place, our native build tools, Maven and Gradle plugins, will pull this config for you to make all of those libraries work for you. And also, if you want to quickly assess which of the libraries that you use in your project will work with GraalVM and native image out of the box, there is this helpful page on our website called Ready for Native Image. If you go there, you will see a long, long list of libraries and frameworks that are known to be testing and working with native image continuously. So this is a quick, helpful way to assist if your project will compile to native image. Now, this is like the best case scenario, those 3 bullet points, but let's talk about things when, for example, you want to use some library that is not friendly towards native image yet. What can you do then? So if you're using, for example, Spring Boot past version 3.0, where they introduced support for GraalVM native image, you can use their own API to programmatically generate hints for native image. So for example, you can say, hey, in this place, I want to do reflection, or I want to load this resource at runtime. Please generate the config for me so those things can work for native image. So if you are on a version of a framework that is already adopted GraalVM native image, you can use the framework support. Now, if you're on a maybe older version of a framework, or you have like no framework at all, or something that you rolled yourself, you can use our tracing agent that is in native image, and this will help you semi-automatically produce this necessary config that native image can include. So the way this works is that you will run your application on the JVM with the agent attached to it, and you will emulate your production workload, and then the agent will look at your application and what is going on, and it will try to produce, config, and reflect all those reflections, serialization, etc., calls that you are making, and produce config for them to make them work in the native image mode. And the last option, and I hope that you will never get to this one, but just for the sake of completeness, you can provide those configuration files yourself. So if I know that I'm making just one small reflection call, I can say, hey, please make this accessible for me. And as a JSON file, it will work. The native image will pick it up and build a native executable with that in mind. So this was a bit complicated, but if you want to use libraries, those are the things that you need to know to make them work with GraalVM and native image. With that being said, let's go back to more fun stuff, and let's see more demos of this actually working in action. So let's go here. Let's clean this up. And I think I want to do a Spring Shell app next. So let's go there. So for the longest time, people have been telling me, such as Josh and others, that Spring Shell should work with GraalVM native image. And in general, we know that GraalVM is a great fit for CLI apps, because you want your CLI apps to be very fast, compact, lightweight, and that's something that native image can do for you. So finally, I gave it a try, and I want to show you this little CLI app. If you would just come here. That is the entire app. It's called Cute LS. So imagine you have your LS, but you're not entirely happy with the way it looks. So you can maybe build a more cute version of it. And then you can just retrieve the files in your current directory, or whatever is the directory you want to look at. And let me move this up, and let me clear all of this. And I have it already compiled to native image, so we can get to the good part and just run it. So let's go ahead and run this. And it runs, and now it's prompting me to do something. So I can do help, and this comes from the Spring Shell itself, but there are some built-in commands. And there is my ls method that actually lists the files in my directory. So let's do this ls. And here is our Qt ls implementation. And it also comes with some additional built-in commands, such as, for example, you can retrieve history. And yeah, it just works. So this is pretty cool, and this is the way you build such applications. And as you can see, it also starts very fast. So it's a really good fit for GraalVM native image. But maybe we can also build something a bit more exciting. And for that, let's go here, native Spring AI. So everyone talks about AI these days, so obviously I have to talk about AI as well. So this is what I have built using Spring AI. We have our little travel recommendation app. Let me just close all of this. Yeah, so this is my application where we will have an endpoint where a user will give us an input on where they want to travel, so which country, what kind of activity they want to do, what is the mood that they are in, and then using Spring AI, we will go and talk to the OpenAI API and generate a recommendation for them. And this is just using not any random OpenAI, but the latest and greatest of GPT 4.0. So let's go ahead and give it a try. And of course, we already have it compiled to native, so we will only be running it in the native image mode because it's the same as the JVM. So let's just do the cool stuff. So travel app, it's on, started fairly fast. And if we go here, localhost, it's immediately here. And here I want to stop for a second, and can we please appreciate my beautiful front-end skills? Thanks. I know that it doesn't look like a lot, it doesn't look impressive by no means, but it looks much better than it did in the first iteration of this app, trust me. So let's say we want to travel to Switzerland, and let's say we want to do hiking. I really don't want to, but that's the kind of thing you have to do if you're traveling to Switzerland, unfortunately. And let's say we're feeling adventurous, so let's see what comes up. And that even says that GPT-4.0 is very fast and very precise, and I think it is precise, but I don't think it's so fast. But anyway, here's our output. So if you want to go to Switzerland, hiking, blah, 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 okay, you need to go to Lauterbrunnen, I guess that's supposed to be right, I don't know. I cannot justify if that's a good recommendation or not, but at least our application works, you can see that. But let's just give it another shot, let's see if we can do something more fun. So let's say we want to go to Spain this time, and we don't want to do hiking, so maybe we want to do something more fun, maybe we want to do cocktails. We are still feeling adventurous, so let's see. Okay, come up. I would recommend visiting Ibiza. Yeah, I would recommend that as well. It's a great recommendation. But anyway, my point here was that you can build such cool applications using GraalVM and use a native image. It all works out of the box, no config needed. But just for the sake of you having all the information, so remember how I mentioned programmatically generating hints and configuration for native image from the framework. So if we go back to my first native Spring Boot app, and I have two more controllers there that are supposed to expose, one that is supposed to be doing reflection, and what is supposed to expose a resource that we will read at runtime. So if I want to generate those hints for native image programmatically from my framework, this is the way I would do it. So if you have your own code that is using reflection, or if you have a library that is supposed to be doing this, but it doesn't work with native image, but you are on Spring Boot 3.0+, this is the way you would make such things work. Okay, let's head back. Yeah, all good. And let's talk about performance, because I'm from the compiler team, so obviously we care about performance a lot, but also all of us, we come from the Java world, so obviously we love our Java for peak throughput, and GVM is excellent at peak performance. We all know that. So what about native image, and can it be at least on par with the JVM when it comes to peak throughput, in addition to what we saw before, so startup, memory usage, etc. And it is not an easy task to accomplish, to make an ahead of time compiled application work as fast as the JVM, because we know that JVM is very good at that. It has profiling, it has different mechanisms to optimizing for your application behavior at runtime. So what about native image and ahead of time compilation, and can it be as fast as JIT? So what do you think, if we have our application compiled to a native executable, can it be as fast as running on the JVM? So do you think it would be as fast? Okay, very skeptical people in the room. Let's see if we can make it work. For that, I brought a pet cleaning application this year. So continue with the pet adoption topic. And let's go there ahead of time. This one, yeah, this is it. So we all know the pet cleaning application, right? But just for the sake of, as a refresher, let me maybe super quickly run it. So let's see, I think it will be target, no, Spring Pet Clinic, yeah, target, and let's just do Spring Pet Clinic. Yeah, that one, okay, it's on. So we can go there, and it's a commonly used benchmarking app supposed to represent your typical enterprise kind of workloads, where you have your web application, you can add owners, you can find owners, you can put entries here, you can create pets, you can schedule visits, etc. So it's commonly used for this kind of benchmarking of what is supposed to emulate real-world workloads. So let's go ahead and benchmark this, and I'm quite proud of the benchmarking setup that we have. It's going to be a bit complicated, but bear with me, I'm very proud of this. So let me show you what we will do here. So this is my first benchmarking setup. For this, we will run on JIT, and the JIT that we will use will be C2, so the standard OpenJDK JIT. And I'm still running on GraalVM. I'm just disabling the Graal JIT, so this is effectively your OpenJDK kind of setup. And we will send a number of requests over time after we get the application to start, and we warm up, and only then we actually benchmark the app. So we are trying to be as scientific about benchmarking as it is possible, at least in a conference kind of setup. So this is our first kind of setup, and we will send load to our app, and the load itself will be scripted over here, while we will create new paths, new openers, we will read data, so we will try to emulate as possible real-world workload rather than creating one endpoint and sending all the load to that endpoint. So let me move this up, and let me start benchmarking this. So bench jet C2. And it will now run on the JVM. And the setup is that we are starting, and then we are waiting for 10 seconds just for the application to properly start. Then we are warming up, so making sure we did some warm-up work. And only then we are running actual kind of benchmarking load that we will analyze. So this is running on the JVM now. We are warming up. This is our warming up output. And we see that our peak throughput here in the warm-up run is about, I would say, 460-ish requests per second, but the JVM does warm up, so we know that the actual benchmarking load will be faster. Let's see. It's running, and it should be coming up. OK, it's on, and the number of requests that we got is 1.4K requests per second. Now, let's do this, and let's try the native app, bench native. OK, it's on, and we will send the exact same load. And what's interesting, now it looks like nothing is happening, and it's because we are doing the same thing. So we are starting, and we are giving the application 10 seconds to just start. 90 image doesn't need it, but we were waiting for the JVM to start, and it's kind of a similar setup. That's why we are now also waiting for those 10 seconds. So it's warming up, and it's exercising now, but even on the warm-up run, you can see that the warm-up numbers are already much better, twice as good as what we saw for the JVM and the warm-up run on the JVM. OK, let's just finish. So as a refresher, on the JVM, we had peak throughput of 1.4K requests per second. And here we have what? 1.1K. It is a bit lower. I would say it's roughly on par, but not exactly. This is still very good for an AOT application, but obviously we can do better. So let's do one final round. Bench native optimized. OK. And as it's running, I will tell you what is going on there. So there is no black magic, no cheating, but there I applied some specific optimizations that you can also apply in your own application to make it run as fast in the native image mode as on the JVM. So one best optimization that you can do with native image is called PGO. And this is profile-guided optimization, where you can build an instrumented version of your binary, and then you can apply relevant workloads to it and collect this profile information so that later you can build an optimized version of your app with those profiles in mind. And this way, you're kind of getting insight from the runtime, which hasn't happened yet, but you're using that information about runtime as you're building your app. And two other things there, since the build is now complete, it's also using G1 GC as our GC option, and it's using AirMark native flag, which specializes the app to my machine. So not for distributing to other users, but it's saying, hey, I want to make the most out of this machine, so please specialize for this machine. Now that that is done, OK, this is even better than I expected, to be honest. It is slightly faster than the JVM, which might be hard to kind of believe in, but it is true, because native image compiles the application ahead of time under closed rule assumption. It can also apply more aggressive optimization, because there is nothing unknown that can happen at runtime that native image is not aware of, so it can be more aggressive in the way it optimizes your app. And I'm afraid I will be running out of time, but I also want to quickly show you the performance charts of running here on the JVM versus native image. So as a part of our benchmarking load, what we also did, we used the tool called PS Record to observe our application behavior and output those charts, which I like a lot because they are very visual. So what is happening here, the red vertical lines, that is CPU usage, and the horizontal blue line, that is memory usage. And that is the JVM version, native image kind of out of the box, and native image with all the possible optimizations. And what is happening here, I see a few things. So remember those 10 seconds when we were just starting our application and give it a chance to properly start up. We see that indeed the JVM does some work as you start your application, while native image is already started and available, and it's ready to serve requests. And when it comes to resources usage, you see that as far as memory and CPU goes, both of them are much lower on native image, though slightly higher in this native optimized version, where if you want to have more throughput, it seems reasonable to also give a bit more memory so you can serve that additional load. Okay, and we have 10 more minutes left, so let's go back to the slides. So we saw peak throughput. We have more measurements like this available on our Medium blog. If you want to optimize also for memory efficiency, it's where native image really shines, because as we have seen, it can give you performance that is comparable to the JVM, but with much less memory usage. So if you want to squeeze the most out of your cloud infrastructure or your local infrastructure, native image can really help you with that. And even if you have some requirements allowed latency, native image can help you meet them as well. Now, best practices. So what do you want to do if you want to build your application? And let's say you want to have cross-platform builds. So this is unfortunately not available in native image out of the box. I cannot build, let's say, on my MacBook and deploy it to my Linux cloud instance because we need some cloud-specific classes. So out of the box, plain on the system, it wouldn't work. But there is a good solution to it, and it's called GitHub Actions. And I really like GitHub Actions. I feel like Microsoft should, start paying me for that or something, because I always mention this in my sessions. But GitHub Actions is a good way to build cross-platform applications with GraalVM, because you can use our GitHub Action, and there you can just have your repo, have your GitHub Actions set up, and build your applications for all those platforms that will work out of the box. And this is something I'm also doing for my demos. If I want to have those binaries available for the platforms, I would just go with GitHub Actions. So GitHub Actions, or whatever is the CI/CD system of your choice, is a good option to have cross-platform builds with native image. Now, during the keynote, the Spring team mentioned a few times build packs and how they like it as a way to build container images for Spring applications. There is also a GraalVM build pack from our team. So if you want to move your application to GraalVM, you could certainly do so even with build packs. And I will not stop here because I'm afraid I will be running out of time, but I did mention security before, and there is a very nice supply chain security session from my friend Thomas Vitale, so I would recommend that you will check it out. And let's say you have your existing application and you want to move it to GraalVM native image, so what are some good practices? And also, if you want to maybe make one photo of my slides, I would say that this is probably the most helpful slide, or I think is the most helpful out of the entire presentation. So if you want to move an existing application to GraalVM native image, the first thing I would suggest is that you add native build tools, and that is Maven and Gradle plugin from our team, and that is a good unified way to build, test native applications with GraalVM. And also, they are integrated with this reachability repo where we have config for all the libraries and frameworks. So if you want to move an existing app, I would suggest to add native build tools, compile your app, and take it from there. Now, for deployment, use CI/CD systems, and also as you're building your application, in general, we recommend that you stay on the JVM, and you compile to native applications maybe in your CI/CD system, or I don't know, once a day, or close to deployment, but you don't need to recompile all the time to make sure that things just work. What we recommend is you build on the JVM, and then you recompile to native, either in your CI/CD, or if you are introducing a new dependency, or if you're attaching things that you know are sensitive to native image, such as reflection, serialization, resources, etc. And for performance optimizations, those 4 bullets, so PGO, ML-enabled PGO that you get out of the box in Oracle GraalVM, G1GC, and a Mark native, that is the best combination from our benchmarks that will give you peak performance on par with the JVM. Now, what is next for GraalVM? I mentioned the GraalVM is being released on the same days as OpenJDK, so every 6 months you have a new release of GraalVM for that specific JDK version. And for that, talking about JDK 22, I want to slightly derail this presentation and show you one more demo that I did for the past release of GraalVM. And for that, I want to show you a modern Java demo from Nikolai Parlok. Do you guys know Nikolai? Yeah, we all know and love Nikolai, right? And he has this very cool demo where he showcases all the latest and coolest Java features, so virtual threads, pattern matching, web server, etc. And it's really nice, and I thought I can just do it maybe even better by adding GraalVM there. So I have this little fork that is native modern Java over here. And what I did to move Nikolai's application to native image is literally just one messy commit that I added to this fork. So I added native Maven plugin. That's why I'm always saying, please add other plugins, and they will help you build your applications with GraalVM. And this is the plugin config, which is standard. And all I did, I set enable preview because we're using Java preview features. And I'm just passing the name because I like this name for my app. So this is all I did to move Nikolai's demo to GraalVM. And now let's see how it will work with GraalVM and native image. OK, maybe we don't need to do this. We can just go up native modern Java. And let me move this higher up and clear this. And the app itself is a GitHub crawler. So if we started target, yeah. So this is my application, and what it does, if you give it a GitHub URL, it will go to that URL. So let's get ourselves a URL, and I like this epic that our team is working on. So it will go, and it will crawl, hopefully, the page, and return us a nice report of all the links that it has found on that page, and qualify those links. And we need to specify our desired crawl depths, and it will run already in the native image mode. So let's see. OK, it runs, and we have a report here, but there is also one more report in a more beautiful way like this. You can also appreciate Nikolai's front-end skills here, clearly. So this is our application running in the native image mode, using all the latest Java features. And if we go back up here, where is it? OK, this is taking too long. Let's try again. Target. So this is my complete app. It's 37 megabytes. It's pretty nice if you want to have smaller, more compact applications that are also using latest Java features. OK, let's see. And I want to briefly mention two big projects that we are working on next. So what is coming up next for GraalVM? One big project that I'm really excited about, it's called layered native images. And I mentioned a few times how a bigger Java application can take a while to compile, just because there is a lot of work to do at build time. We understand that, and we want to give you a better developer experience. So for that, we are working on a new way to build native images that will be more modular, where you can define, for example, let's say I have my Spring application, and I can say, hey, this will be my JDK core, this is my Spring core, and I compile those files once. So they will be not exactly, but kind of like shared libraries. And then every time I'm introducing a change into my application, I'm only recompiling this thin layer that is my application code, and then those base layers stay compiled. So with this, we think we can take compilation times down to just a matter of seconds, because I'm only recompiling my user code and not recompiling everything else from the framework, from JDK, etc. And that's good for developer experience, clearly, because you will have faster builds. But there is one more benefit, and that's when you deploy your application, you can say, hey, I want to have my 5 instances of my Spring application. But since it's the same Spring application, just more instances of it, they can reshare the JDK base, the Spring base, Spring Web, etc. So you can also benefit from the resources sharing in the cloud, and this way use your resources even more efficiently. This is a very big project. It will take us a while to make happen, but I saw some prototypes already. It's looking very promising. So I hope that soon we will see some more tangible results that all of us can try. And another project with a very cool name that I like a lot is called GraalOS, which is kind of an operating system based on GraalVM, where we are working on giving you a deployment platform where you can deploy your application as native images rather than container images. So you just compile the application, you give it to us, and we will take care of the scaling, resources sharing, security, etc. for you. So those are two biggest things that we are working on. And with that, I will start wrapping up. So I hope that you can see how GraalVM and native image can be good for your applications in a number of ways. So it's great for startup, it's great for resources usage, even for peak performance that you want to have on par with the JVM, it's possible to do so with GraalVM and native image. And if you want to get started with GraalVM, here's a number of things that you can do. So maybe you want to take a photo or just navigate to any of those places to get started with GraalVM. As always, the easiest way to do it is probably to pull it from SDKman. And if you have any questions, I will be here those 2 days, or you can just ping me on Twitter, or this other QR code is all the demos that I have shown today. So if you want to find them, that will be the place. With that, please rate the session, and thank you so much for coming. Thank you.